you're supposed to modify the existing binary search and sequential search to count how many times we're testing to see whether the key is equal to the array midpoint. Not how many times it's found, but every time it looks, it says, is this equal to the key? Is this equal to the key? Is this equal to the key? You count that up.
Okay, I just thought one of the bits was weird at work and was asking for the
So every time you're checking the equals, and only the equals, add to a count. So it's not really that, those are pretty easy, right? The only hard part there is somebody's thinking how to structure that test and repetitions code. And even that's not so bad. It's just a loop with another count. Yeah, question?
So in regards to the assignment, so I noticed that the way that it's searching for it, it will let you do like, it will also do main. Can we modify the main method to add a space after that?
So the question is, if your phrase is just then it will find stuff like boy, but it will also find and then, that's the question, right?
Yeah, so would it be all right if in the main method we put a plus and a space string, just so I could search explicitly?
I would force, that's valid, right? Make them type a space if that's the phrase they want. If you want to search for a space, then make them type in a space. And just leave it at that,
Just make sure that was okay.
Yeah. So don't try to hack it too much to jump ahead of what they're doing.
In the phrase completer, there's the method that searches for the n number of matches has an initial hit, so an initial index. What am I supposed to do with that hit?
So there's two phases to this. One is given a start phrase, you do binary search to see if that can match any phrase that's in our 300,000 phrase dictionary, right? And if it doesn't find it, it says phrase not found and stops. That's the end of the process. If it does find it, so there's this huge list of phrases, and if it finds a match here at 1,238, there's something that starts with here, right? Well, given the structure of the file, where it's all alphabetical, all the phrases that are also going to match are in the neighborhood of that phrase. And so this is telling you, if I want to find more matches, they're going to be somewhere collected around this location here, right? So that start index is telling you where you can start looking for the other n matches that you're trying to find.
Okay.
So
So should I include it in my return array or not?
include
Should I already know about it?
include this one? Yeah, it should count as one of the matches. Okay. Actually, it doesn't have to count as one of them. If you can find 7 matches through whatever weird process you're using that don't include that, then that's fine. If there's only like 3 matches and you need 7, then you better include that one because it's one that actually matches, right? Right. So there's sort of 2 cases. One is that you have not enough phrases to match up with your starter phrase, and then you better find all of them and put null in the extra spaces. Or the other possibility is that you have too many phrases that match, and then you just have to pick the first 7 that you find, or however you want to do it is fine. But so there's sort of 2 different possibilities there. Right? Anything else? Yeah.
Words like can't, doesn't, didn't have a weird space in between and not. Should we account for that in our search, or should we just
Yes, okay, so contractions, there's some standard that I'm not that familiar with for these kind of things that they obviously, so in the phrases, instead of can't, it counts it as two words, right? Because they really are sort of 2 words. Don't do anything special there, assume that the person's going to type in this weird N''T if that's what they want. Pretend they're all into this linguistic kind of stuff and understand why these phrases are broken up like that, right? So anyway, they process these as 2 separate words, not as one. And we're never going to find that phrase in there, but assume the person typing the question matches our phrase stuff. But yeah, that's a good point. I meant to mention something about that because it's very weird to read it like this. It's like, you know, what weird not English is this kind of thing? Anything else? Yeah.
It's a number of the matched phrases is more than the limitation. Should I randomly choose the matched phrases or can I return the same thing every time?
So the question is, if you're putting in a simple thing like this, and there's like 100 phrases that match, and you're only supposed to return 7 of them, right? As long as you return 7 of them, I don't care. You can do whatever you want. It can be the same 7 if you keep asking for that phrase over and over. It can be some random thing.
So for the same starting phrase, I can choose the same 7 phrases.
Yeah.
Every time.
So if you type in A, you can pick the same 7 every time. In fact, I'd be surprised if you had some method that didn't return the same 7 every time, right? Like it's harder to do this kind of randomly than do it rigorously. So my one other suggestion is, you know, you're given this starter point, you know that there's a matching phrase here, you know there's structure in the neighborhood, that the matching phrases, there could be some before it, there could be some after it. You need to search around and make sure you've found at least 7 in that neighborhood, or however, whatever that, you know, limit number is. But you can use that as a starting point. And then just kind of, you know, try to figure out some way to look backwards and forwards and figure out how to pick up all the ones that you need. Okay? Don't be like just stabbing randomly into this thing and hoping. I mean, I guess you know, I didn't say. What you should not do is just randomly look at the entire array until you hit 7 of them or something like that, right? That's not using this information properly. There's some useful information the binary search is giving you here. So don't just like ignore that and just do whatever random thing after that. I didn't really anticipate you doing that, but maybe you're headed in that direction. Anything else? All right, I was glad to see some stuff on the discussion boards and some questions by email over the weekend and stuff. It's always good to, again, get started on this a little bit. One of my colleagues just got back from the CS Educators Conference, and someone was saying there that if someone works on the assignment like 10 minutes, even just 10 minutes a day, like in advance, their chance of success goes up like super dramatically. So you don't have to do it all like, you know, on Friday or something, but if you spend 10 minutes looking at it, I think it will help you a lot. All right. Last time we started talking about objects, and there's a lot of stuff to learn about how these work in Java and really all the programming languages. It's a different way of thinking about computation. There's a lot of sort of syntax that's involved in making it work. Like, so far we've been learning stuff like if statements, and it's an if, and then parentheses with a condition inside, and then statement block. You know, somehow there's only like a small number of things to keep track of here. With classes, all of a sudden there's going to be sort of like a dozen things that all work together to make the class work well. So it's a little bit more of a complicated structure, and you have to really work to see the patterns that are available here and make sure that you're picking up on how these work. So we're going to keep kind of showing you a bunch of different classes, and hopefully you'll see the commonalities between them and realize that I'm not inventing this like from scratch each time, that I'm sort of following some patterns here that are useful. So again, why are we doing this? You know, we can do all of what we're going to try to show you. We can do with our procedural style. This is not adding additional power that's inaccessible with other kinds of programming. But through experience, people have found that on larger projects, organizing things into classes like this really helps the chances of success of making this all work, that we can handle the complexity of it better. And so this is a valuable skill to pick up. And certainly most modern development follows this object-oriented programming, so you'd be totally lost like in a job without it. I will say back in the early 90s, I think, this is when it's sort of a second wave of object-oriented. There wasn't always been an object-oriented programming, essentially. But there was like another wave of this that was really pushing out other languages. And for example, the Department of Defense, which does a lot of big programming projects, was trying to use object-oriented programming And at a certain point, they decided that only half of their programmers were capable of like getting into this mindset and actually understanding how object-oriented programming works. Now, of course, we're working under the assumption that all of you can get this mindset. And it's nothing so tricky here, right? But if you're some person who had been working on programming for 30 years and had a certain stuck mindset, it was hard for them to transition to object-oriented programming. So we try to hit you much earlier with object-oriented programming, hopefully before you get stuck into procedural style stuff. So a class, again, has several purposes. In your mind, you should realize that it's connecting data, the instance variables, with the code that works on the instance variables, the methods, right? And they're tightly coupled together into this one structure. Another goal is to put a barrier around that data and those computations so that, for example, people cannot get access to that data without working through the methods you have provided. And that's just making sure that people use the data appropriately. And we believe that this style of programming allows for safer code, basically more bulletproof code, and it helps us maintain code. In other words, we can make changes more easily. So I want to look at some example, and hopefully you'll see why I think that's true. So let me go to Eclipse, and we're going to make a quick circle class. And this is going to be a very sort of useless example class. But if you're thinking about a circle, what's something important to know about a circle, do you think? Yeah, it's radius, okay? Now, you could also imagine a position, but fundamentally a circle has a size, and that's sort of all the most important thing about it, okay? So we're going to add an instance variable. In other words, a variable that's accessible to all the objects in the class. And we're going to make this a, well, I'm going to make it public at first, okay? You know, a public double called radius. So now if we make instances of this circle class, then again your mental model should be that somewhere on the heap there's going to be a circle and it has storage for this radius here, right? And every new object we make a circle has its own box with its own place to store the stuff. Now, what do I need to successfully make one of these objects? Like, what kind of code do I need to help build a circle? A constructor. We need a constructor, right? A constructor, again, is a special method that tells us how to initialize the values held in an object. And so that's going to be a public, doesn't have a return type, circle. And I'm going to pass in a value, initial radius, and in here I can set radius equal to initial radius. So again, constructors are super important. They are there to make sure that when we build an object, it's built into some kind of consistent, safe state. In other words, it has values where it needs values. And the sad thing about constructors is that typically the code is super boring. You have the instance variable you want to set the value for, and you have the value you want to set it to, right? And we assign this value over there. So a lot of times these constructors are just a long list of radius equals initial radius, position x equals initial position x, position y equals initial position y, and you're just like, ugh, this is, you know, tedious. But you only have to do it once. So here we have our instance variable. It doesn't have a value here. We just are saying that all objects of this class contain one of these things. And then we are initializing that value down in the constructor. And if I wanted to use this, I can do it inside main here. I can make an object of type circle. So the variable reference is of type circle. And I'm going to call this the usual boring kind of thing, circle 1. And it is a new circle with a radius 10. All right, so if I were to run this program, it would search for main because that's where programs start, in main. It would say, okay, I want to have a variable circle 1, and I want to make that out of something that has a 10 passed to this constructor. Initial radius would be 10 in this case. That 10 would get assigned to radius, and the circle 1 would remember that value as long as it's in scope, as long as it's alive, kind of thing. So in this case, we would have, again, circle 1. That is a reference variable. It references that object we made that has a 10 stored in the radius. Okay? And just for kicks, maybe I'll do one other quick thing. Circle C2 equals circle 1. What's happening here? What have I done in this case? What do you think?
You've assigned C2 to equal the same object as the first one.
I've not made a new circle object here. I've made a new reference to a circle that happens to reference the same object that circle 1 references, right? That's what that kind of assignment does for us. It doesn't make a new object. It just says, I also want to reference that object. Okay. Now, let's go to a different class. It's in the same package, lecture 22. And in here, I can make a circle. And I'll call it C1. New circle 5. And let's print out C1 dot radius here. So I can run this, and it prints out 5. Notice this is a different class, but because it's in the same package, I can access the class that's also in the same package, right? I don't have to do anything special. That whole package structure kind of gives more immediate access to things, even though they're in separate files, right? If this were in a different package, I would have to import wherever this thing lives. I have to do an import on a circle class in order to use it. Now, let's see, what do I want to do with this now? Let's print out something more complicated than that. Let's print out C1 perimeter is new line there. New line. What's the perimeter of a circle? 2 pi r. Yeah, so r is radius. So I'm going to say it's a radius times 2.0 times math.pi. So we can pull in pi from this math package here, math class really. All right, and if I run it now, I've got this beautiful number here, so I can access radius and so on here and figure out its perimeter. Now, let's say I'm back in circle, and I don't know, there's like this push against using radius, like for circles, this certain, like, you guys know, like by heart and some other, like during Pi Day, people are like, oh, radius is a dumb measure for circles, we should use, what do they call it, tau or something like that. But let's say I'm like, for whatever reason, radius no longer feels like the best way to represent the size of the circle. And instead, I want to use diameter. Okay? So at some point, this class is not representing stuff internally the way I think is most efficient. I mean, going radius diameter is not really proving that point, but let's say this was some more complicated thing. And I wanted to change how I'm representing some of this information inside the class. The question is, where do I have to update this radius? Well, here I can still use initial radius, but it's times 2, right? So I can convert this constructor to still store stuff as diameter. Diameter is twice the radius. And that's all this thing really does. And if I run this, it's nothing just coming out, that's fine. But if I try to run this now, it gives me all these errors and says, unresolved, radius cannot be resolved, there's not a field. So these error messages call instance variables fields, that's another term for these things. So it's saying, I don't know about radius, right? And that makes sense because I got rid of radius and made it diameter. Now the problem is, if I have a class, I'm expecting other code to use that class. Typically, these things are not like self-contained things. They're part of some larger puzzle. Like this circle might be part of some geometry project, and I have points and lines and circles and squares and, you know, hyperplanes and all sorts of stuff, right? And so I'm making a circle with the idea that other people are going to build upon that and make some cool other project with it. If I have this public instance variable, and I'm letting people use this value elsewhere, I have no control over how many times radius or diameter shows up in other classes, right? Because other people are writing code and just saying, I want to use that radius, and so on. And so if I ever want to change circle, I have to somehow figure out how many millions of other places, who knows where this code is spread, how many other places I have to change radius to diameter, right? I don't have control over it. It's all over the place. And so that's sort of the fatal flaw of really procedural programming, is that you can't control where that data gets used by other people. And so when you change it yourself, you can't say how to update it anymore. So what should we do instead? Instead, we should make this private. So no one can use it, right? This way, no one can access that diameter anymore. But we still want them to be able to use our circle class. And that's where we're going to build these getters and setters that provide an interface, a well-defined interface for how people should be interacting with objects here. So I'm going to make a public, let's not put it down below main here. I'm going to make a public, the getter is going to be a double, get radius, and here I'm going to return diameter divided by 2. And then over here, instead of grabbing radius directly, I'm going to call this getter method get radius, and I'm going to ask the class how big its radius is. Okay? So if I ran this now, it works. Now, there's still some of you who are thinking like, okay, before we had an instance variable and that was public, now we have this get radius that's public. So what's the big deal? There's no difference here, right? But the big difference is, if I wanted to go back to representing my circle with a radius, I would set radius here and get rid of the 2.0 times. And I would return radius here. And at that point, I have now changed over my class from diameter to radius. But other class here always uses get radius, and they don't have to change anything, right? So I've managed to control the sort of spread of where changes have to propagate to only be within this class here. And that is a huge, huge advantage if you're talking about 50 people working together on some big code base and a million lines of code and all that kind of stuff, that I can restrict changes to be just this class and not somewhere else.
In this instance, it would still change the way they define it. So we would probably, because now we're setting it with a double value or a radius value instead of a. Actually, never mind. We still got a radius from the beginning.
Yeah, we could always say this is a radius here, right?
Yeah.
And then you could do some math to shift it to whatever form you want.
Right. I thought we'd call it a diameter in the first place.
Now, in fact, once we have this sort of idea down, we can recognize that some people want diameter sometimes, and sometimes people want radii. And so we can add another getter. Let's comment this as a getter here. A getter. And let's make another getter. And this time I'm going to call it get diameter. And now I'm going to return radius times 2. So not only have I not restricted people to be a certain kind of access to my circle class, I've provided both accesses at the same time. And you can ask it whichever one is most convenient to you. I can ask for the radius, or I can ask for the diameter, right? So that's a really beautiful thing about it. And in fact, I could also add something that is not sort of a direct getter, but more of a computation, like get area, right? And I don't store the area in here, but I can compute it easily enough, and I don't have to make you compute it, so I can add a method that computes area, pi r squared, and basically provide information in a form that I think is useful to you, not the way only that I'm storing it internally inside my object. So the advantage here is that sometimes the way you store data might have a certain form that makes it efficient to process. And again, this circle doesn't really highlight that kind of thing, but maybe you have some nice data structure that makes your internal computations be really easy. But then you can provide a bunch of well thought out methods that provide access to that data in a form that's easier for other people to digest, not some super complicated string of binary numbers or something like that, which maybe is good for our internals, but we can convert it into something useful for you as a process of extracting it out of the class. Okay, so this idea of divorcing, of separating the internal representation from the interface is really a super key aspect of object-oriented programming, that we want to split those two, make an abstraction. The abstraction is that we think a circle is one of these getters here, get radius or get diameter, but inside there could be some very complicated details about what the actual representation is, right? I mean, if I wanted to, I could represent this circle as its area and then kind of divide to get back to the diameter or radius if I wanted, So I could make all sorts of decisions about how to represent it internally, but it doesn't change how people interact with that class through these methods. Okay, questions on sort of the getter idea here? And you'll find that, of course, if you're making your own class, the hard part is figuring out what is a nice form for other people to access your internal data. And so it takes sort of design experience to figure out nice ways to set up this code. And it evolves over time sometimes. Now, again, just as an example, we can have setters. And a setter changes some internal state of the object. And so public void set radius, and I'm going to take in a double new radius. And in here I'm just going to say radius equals new radius. We can make another setter. That seems like a good way to interact with this object. And I can set the diameter, even though I'm not storing the diameter, right? And radius is now the new diameter divided by 2.0. So again, I'm giving some flexibility in how people are changing my object. They can either change it by setting the radius or setting the diameter. And we're still storing it internally always as a radius, but I can do a little conversion and make sure that this is doing something meaningful to update my object, but through a different name. So again, that's I think a huge win here. Now we're giving some flexibility in how we interact with this kind of thing. All right. Now I want you to be kind of alert again. There's a pattern here. The getters are returning some internal value that has some type. Like in this case, we know that radius is a double type. So we're going to return double out of here, right? So getters return a value and have a return type equal to whatever instance variable type you're interested in. Setters are not returning a value. They are changing the internally stored value in that object. And so they have a void return type. They don't compute something and return it. Instead, they have what we call a side effect. And the side effect is that instance variable has changed its value. All right? And so, again, when it's a test or you're writing your own code, I always have to kind of take a little breath. Okay, getters, returning something, a value, right? I'm getting a value. Setter is not returning something, so it's void. I have to kind of checklist myself through the pattern here, and it's not that hard. I'm just not that smart. So don't, get in the same habit. Think about what's going on with a getter. I'm getting a value out of it, so I have to return something. Setting, I'm just changing a value internally. I don't have to return something. So don't get sort of stuck on that kind of stuff. Okay, questions on setter getter aspect here so far? Yeah.
So kind of like going back to that example that you did that's behind you, where you put C2 references C1. If you put a setter like that sets to C2, would it also change the reference group from circle 1?
Yeah, so that's really the key thing about the difference between references and storing values directly. So if I were to say circle1 dot set diameter, why not, to be 10, and then I were to print out C2 radius and asked C2 what its get radius is. Let's see, are these different? Let's see. So we should get a 5 out of here, right? So C2 radius is 5. So we changed, C1 says, change the diameter to 10, that makes a radius of 5, right? And then we said, C2, get the radius, and that's the 5, and print it out. So those both reference the same object. And again, it's an easy place to get confused, right? These have different variable names, and so you instinctively think those are different things you're storing, but they're both references to the same object here. And so this is a big source of bugs, essentially.
In good practice, when would you actually use it where you're calling two objects or an object from two different names? Is that ever a good practice?
Yeah, so the main place this happens really is when we are doing something like we're passing it as a parameter, as an argument to something. So if I had a not a method, I mean, not part of the class, but some just sort of, let's say, compute area. And this is going to be like a static method that takes in a circle. And down here, I call it C2, or I call compute area on C2. C and C2 will both be referencing the same object in this case, right? So C2 is here. It references some circle object. When I make this call, it says, okay, assign the same value to C that C2 holds. C2 is a reference to this object, so C is the same reference value that C2 has in it. So it references this as well. And in here, if I were to change radius on C, it would basically change it on C2 as well. So this kind of thing is really legal, but like you said, there's no really good reason to do it in code. Every once in a while, people do something kind of tricky with this, where they might call this like temp or something like that, and they're looping, and they sort of want to use that temp word to show something is going on, but I've never been too fond of it, where you're so in one chunk of code, you have two things referencing the same object. It's not, I think it's just a source of confusion. All right, so again, this idea of object holding references is also fundamental to everything we're doing in Java, and it's also a source of confusion because some of you are going to think, if I pass an int in here and I change that int in here, it doesn't change the int here, right? That's because int is a primitive type. But if it's an object, then these are really references to objects, and it allows you to basically access the same object inside the method up here.
So are instance variables stored on the heap?
So the object themselves are stored on the heap. The reference variables are stored on the stack. So these values that say this is where this thing is are created in some scope and disappear when that scope goes away. But this only goes away when there's no more things referencing it. And that's what's called the garbage collection, when it goes through and decides whether it knows about it anymore.
So it would be correct to say then that the object contains the instance variables? That's how we talk about it?
each object has its own set of instance variables, own storage for its instance variables. Yeah. And eventually, these instance variables could be objects, references themselves, and so they could be pointing to other objects on the heap. It can get pretty complicated, basically. We'll see some examples of that. So I think really here again, there's a couple main things. You should understand what happens with this set of code here. Like you should have the correct mental model, which is this kind of model, for what's happening there. And the other one that's key in my mind is that you should understand that there's a difference between your internal representation in a class, private double radius, and the interface that you expose to other code, which is get radius, get diameter, that kind of stuff, right? There's a clear distinction between those two, and the idea is that we are allowing other classes to use the exposed interface, but that makes it so that we can do whatever we want to the internal representation as long as we keep that exposed interface consistent. So other code doesn't have to change when we change as well. All right, so those are I think, two concepts you're going to see for the next however long you're staying in computer science, and it comes up over and over again. And so I switch off teaching 3505, which is the fourth course in this programming sequence, group software engineering, and there are still people that are really struggling with this concept of encapsulation. And so I do not want to see you again in a year and a half or whatever and have you be bad at this, because I know I'm responsible. So, so I try to get this under control. Now, let's look at one sort of subtlety of this. So if I have, let's go to my setter. So normally, we can't have something like so it's complaint, it's underlined here, right? There's a red underline here. Why is it not liking me declaring a local variable in this method? So I just want to add another variable. What's wrong with this? Yeah. Yeah, so you can't have two variables of the same name and the same scope. So this parameter here counts as being in the scope of set radius. And in fact here, if I go here, it says duplicate local variable new radius, right? So I can't have something with the same name. I can't redeclare it in the same scope. It doesn't know which one is which here. So we already know that. We've seen that happen before. Now up here, in my constructor, let's see, where do I want to do this? Let's do it here. If I say double radius equals 1, it's not red underlined. It's saying that the value of the local variable radius is not used. So somehow this is legal. All right? I have radius here. Why is this potentially in conflict with something? Where else do we know about radius? It's up here. It's an instance variable, right? And I can use that instance variable in this scope. So somehow it's not complaining when I have an instance variable the same name as a local variable in a method. And this is a bad thing because if I were to write code like this, it's legal, but it's kind of nonsense, right? Like, what would this mean? Pass in radius. Like, what do you think first of all, there's my intent. What was my intent in writing this code? Like, what am I trying to do here? I'm trying to initialize the instance variable radius with this parameter called radius, right? And there are some of you that are going to write this code at some point in your life. But it actually thinks this radius is this radius here. So it's just, now it's just sort of going around in a circle and saying, pass in a value for radius, and then assign it to itself, and say you're done, basically. And this thing never gets a value. Okay? So in this case, I think if we were to run this, yeah. Oh, I used the set diameter. Okay, that's not broken. Okay, so it says the radius is 0. So even though we initialized it with 10, that 10 never made it into this instance variable here. All right? So there's a couple questions here. Since we're so strict about duplicate names, why do they let us do this with duplicate between an instance variable and a local variable? And the problem is they can't really answer that yet because it comes up when we start doing what's called inheritance, where you start saying this class is based on another class. And they don't want to have you have to know everything to know about that class up there, and so they let this happen. And we'll, in a few weeks that will become a little clearer, but right now it just seems like a silly loophole that Java left in its sort of rule set to let you do this kind of thing. So then the other question is, if you are allowed to do this, what can we do about it? And there is a way to say when something is part of like an instance variable, and when something is local. So there's a keyword called this, and this causes no end of problems. This refers to the object that called the method. So we can use this inside class code, like here, or here. And when you use it here, it means whatever object called this method, this is the same thing. So let's see if this is true or not. So first of all, let's do a system out on circle 1. And I'm going to get rid of this print here. Okay, so if I do a print line on circle 1, it prints out that weird reference form that kind of says this is some reference to some object that exists somewhere on the heap, and this is sort of some sort of address for that. Now, I'm going to double radius equals circle 1 dot get radius. So I'm expecting this is going to ask circle 1 what its radius is. Apparently that's 10, and we're deciding to radius here. But in get radius, I'm going to do a system out and print out this. This is a reference to the object that called this method. Okay? In this particular case, who called get radius? We go look. Circle 1 is the object that called get radius. So we're expecting this to have the same reference value as circle 1. If I run this, those are the same references, okay? So this is an automatic name, kind of like when I was saying we could pass in a parameter to a method and it takes on the same reference value as the argument. This, inside class code, says whoever called this method be a reference to that object. All right, it allows me to access, to kind of know who is calling this object. You get that? So in this case, if I have circle 1, and it has a radius of 10, and it references this object, inside class code, this is sort of an automatic variable that also references that same object. If I were to call with C3, which references another object, this, when I'm inside a method called by C3, would reference the C3 object. All right? It's not stuck on one object. It's whoever is calling, whoever called the method is this. this case, we only have one object, this one circle here, right? But, so let's make circle 2 be another new circle with a radius of 5. And now if I were to get the radius for C2, and we better say that this is this here. When we called it off a circle, it got the same reference as circle. And then we changed to C2, which is a new object, asked for the get radius. And now this inside of get radius is referring to the C2 object. All right? So this can only be used inside the class code and refers to the object that called the method. That's all you have to know about it. But somehow saying that phrase over and over in your head doesn't seem to make it mean anything. So you got to kind of understand what's going on here.
That object location is on the stack.
This is a heap thing.
Oh, that's right. We made it.
Objects
We made
hang
it
on the
more
heap,
memory.
right? So this is not complicated, but you must know what it means. It doesn't talk about one object, it talks about any object that is calling this method. Okay?